Hello,
Hey, Aiden, how are you?
I'm doing good. How are you?
Good. So probably be good if you just suggested out of these questions
Yeah.
what what to focus on.
Mm-hmm. Okay.
There we go.
Yeah.
Do that. Do that. Completing the square. The main ones are vertex, um, completing the square, factoring to
Mhm.
find the x-intercepts. The triangles, you had to know how to use the sine law, the cosine law, and
Mhm.
Pythagoras. And it all depends which you find more difficult.
Uh, Probably like the stuff with like the reference angle, the coterminal angle, and all that stuff. It's
Right.
like pretty basic stuff, but like I just haven't really paid so much attention onto it. I've kind of just been like
Right.
overlooking it and doing like the
The harder stuff.
yeah, exactly. So like
So the terminology is always annoying.
yeah.
Okay. We used to call this, let's say the line was here. Let's just say the line was right
Here, wait.
over.
I
Oh,
can't see. Are
sorry.
you
I
sharing
forgot to
screen?
share. I forgot to share. My bad.
No worries.
So I'll go over here. There we go. We can do it right away. There we go. Let's say this blue line represents where it is.
Yeah.
Okay. The distance from the beginning, this is considered the beginning in for the Cartesian graph for unit circle. The
Yeah.
distance from
Uh-huh.
there to there
Uh-huh.
is called the terminal angle.
Terminal.
Okay.
Mm-hmm.
The any line. So a circle, the problem with the circle is everyone thinks, okay, 360 and I'm done.
Mm-hmm.
But the reality is you can go round and around and around and around.
Yeah.
It's endless circles. You can also
Yes.
go the opposite way. You can also go the opposite way, which is called a negative degree. So if you see negative
Uh-huh.
110, it's this way.
Yes.
It's this way, 90 plus 20 more. It's there.
Mm-hmm.
If I look at negative 110 there, I'll give you an example now of a coterminal angle. Coterminal is another angle that ends up either in this spot or this spot. Doesn't matter which one we use. So I'll go with the blue first. Let's say that blue one is 135 degrees. Let's say it's 90 plus 45. All right. I'll give you one coterminal angle, would be all the way around and
Yes.
then there again.
Oh,
So all the
uh-huh.
way around would be 360,
Yes.
and there again would be another 135. So we're talking at the angle 495. So
Mm-hmm.
495 is what we call in this case coterminal. 495 degrees is
Yep.
coterminal
Mm-hmm.
to 135 degrees. In other words, it ends up in the same spot, it just takes a different route.
Yeah.
Okay?
Yes.
That's
Okay.
all coterminal means. You can
Mm-hmm.
also get so there's a million answers to coterminal because I can go by it around again.
Yeah.
And that means I'm going to add another 360, 360, so 720, plus the
Mm-hmm.
original angle, 135. So that means these are all coterminal angles here. 7 or 855
Mm-hmm.
is coterminal to 495, is
Yeah.
coterminal to my original 135. They all end up in the same spot. So they would all use the
Yes.
same special triangles. They would all have the same sine value. They would all have the same
Mm-hmm.
cosine and tangent. They're all essentially the same angle. But the secret is just to recognize that you can keep going. They just want you to understand that you can keep going. There's more than just one circle.
Yes.
The one circle is what we learn. And in reality, what we're really learning is the first 90 degrees. And then we're applying it to each of the other areas. That's really what we're learning.
Okay.
And then after we
Yeah.
do that, we learn this. So that's terminal and coterminal. Okay.
Uh-huh.
Now let's go back to the terminal. Terminal is when I have an arm there and I start here and I have to measure this angle here. And
Mm-hmm.
that's my coterminal angle, 135. Let's say they tell you it's 135. A terminal angle of 135. And they ask you to find the reference angle. This is also what we used to call the acute angle. It's the same thing. And this is a lot easier to think of because acute means less than 90. The reference angle is right over here. The
200、
distance between the
280
arm and the nearest x-axis.
Mhm.
This here
Okay.
in there is the reference angle.
Yeah.
375
And we can figure it out if they give us the terminal, right? Because the terminal is 135. The terminal here was 135 in this example. And we know if we went the full distance all the way to here, it'd be 180, right?
Mhm.
So we know that this
Yeah.
little angle here is the difference between 180 and 135. So we know in this case, the reference angle is 45.
Yes. Okay.
115
So the terminal angle is 135 and the reference angle is
187
45. Now we spend a lot of our time in this chapter
187
working with the reference angle and figuring out the terminal angle
Okay.
over and over again. We end up figuring out that's because those special triangles we practiced all had 45, 30, and 60 in them. You remember those triangles we made up? We
I
figured
do.
out?
Yes.
Yeah. So they
Mhm.
all had these possible degrees, 45, 30, and 60. Well, you can't
Yeah.
get those degrees going this far. You can only get them as a reference angle.
Mhm.
So that's the difference between reference angle, terminal, and coterminal. Good?
Yes. Yeah.
I'd say this one's the one to really, I mean, terminal sort of you get used to saying. And then if you
Mhm.
think of coterminal as just the same as terminal, just a different route. Reference angle is this one. We're always figuring out the reference angle. So in this question, they tell us the terminal angle is 168.
Okay.
Oh, by the way, so what I call
可以加个90
terminal, they also
所
call
以呢，这个需要
standard
它能
position.
加90，它能加
See
100
this right
Okay.
here? Standard position.
Yes.
就是但是
So
不能
terminal for them can also say, they can also say
只能
standard
减去前
position,
面的数。
Okay.
which is kind of goofy since they're using the term coterminal. But anyway,
Yeah.
standard position and terminal are the same thing. So in this
Okay.
first question they give us, instead of 135, they tell us the standard angle or the terminal angle is 168. Okay, that's what
Okay.
they're telling us. They're telling us the terminal angle in this green is 168, and they want to know the reference angle right over here. How would we figure it out?
You do 180 minus 168.
Yeah, that's right. It's 22 degrees. So
Mhm.
that's the reference angle. And also,
Yes.
I want you to be acutely aware of when you do this test and you see it's worth 1 point or whatever.
Yeah.
You know instantly that that it's not. It should be easy to figure out. So when you see it's worth
Yeah.
1 point or whatever,
Mhm.
identify a positive coterminal angle that matches the standard angle of minus 115. So let's look at this. Whenever you see minus,
Mhm.
it's going this way. So here's
Yeah.
90, right? There's 90, right?
Yes.
How much more to get to 115 in this direction? If I've
Not
gone
a lot.
90,
Like a little bit. Keep going that direction.
yeah,
Yeah,
I know,
they're like
but I
there.
want a number. How much more after 90 to reach 115?
Oh.
So I'm trying to get to 115. I got 90. 10 more is how much?
25 more.
Yeah. So that means I have to go 25 more. So that means negative 115 is this distance, 90 and another 25, right?
Mhm.
But it wants to know a positive, so that's this way. Standard angle or terminal angle. So it wants me to get to the same spot as this angle,
Mhm.
right?
So it's
Since I know that it's 360
it's
to there, I got to go 360 back.
115.
So how would I write that in math? 360.
Minus 115.
Yeah, what's minus 100? 360 minus 100?
The answer's 245.
Yeah,
Hey?
so-
Can't you do 270 minus 25?
Yeah, you could for sure if you want to.
Yeah.
So 270 minus 25 is 245.
Yeah.
Yeah, you could if
Okay.
you're fine with that, but that means you have to visually figure out where 115 is.
Mm-hmm.
Personally, I think it's just easier to say, well, minus 115 is the same as 360
Okay.
minus 115. This is the same as 360 minus 100 minus 15.
Yeah.
Because 360 minus 100 is easy. It's 260.
Hmm.
And then 260 minus 15 is the same as minus 10 minus 5. 260 minus 10 is easy. It's 250.
Hmm.
And then 250 minus 5 is 245.
Yeah.
So that's our answer. The answer that a standard positive position, I can answer
Hmm.
positive 245 degrees.
Yeah.
I can also, if I wanted to be a smart ass, I could go, okay, 360 and another 245. I can add 360 to it and say 615 is also going to end up in the same spot.
Hmm.
So you can end up answering, if you wanted 3 positive terminal angles, you would keep adding 360. Whatever you found here, see our 245,
Yeah.
you would just keep adding 3. If you wanted more, you just keep adding 360 to it.
Okay. Yes.
Because you can come up with endless
Hmm.
angles that end up in the same spot. By the way, now I'm going to trick you a little bit. What's the reference angle? Let's see if you remember what the reference angle is to this orange bar right here. What's
the reference angle for that one. It's that angle is negative 115 though, hey? Yeah.
Yep. And that's why I put it in 90 and then 25. So first of all, where is the reference angle?
It's to the orange line to the top.
That's right. It's the closest x-axis.
Hmm. Hmm.
It's not too hard to figure out if you were good with the...
So what? It would be
How much does each square hold? That's 90.
90.
That's another 90.
90.
That's
Yeah.
another 90.
Yeah. Oh, so it's 25 minus 90.
Almost 90 minus 25 because we're measuring positive.
Oh yeah.
So 90 minus 20 is 70. So 70 minus 5 is...
65.
Yeah. And you're right. It's 90 minus 25. And even if you got it the wrong way, if you did 25 minus 90, it ended up saying minus 65. And you'd say, oh, no,
Mhm.
reference angles are always positive. And you just go, okay, it's that.
Okay.
So that's the reference angle. That's the negative angle. That's the positive. They call it standard angle
Hmm.
or terminal angle. Good?
Good. Yes. Good.
All
Yeah.
right.
Okay.
What are they getting at here? Notice. So here's the other thing I want you to memorize, Aiden. When I say exact, it
Hmm.
means you're not using your calculator. So what do you
Okay.
think we have to figure out for sine of 300?
Um, the what's it called? The like sin, cos, tan, like the
Yeah,
different sides.
SOHCAHTOA.
Like
SOHCAHTOA, it's
yeah.
called.
Mhm.
Yeah. But first of all, where's 300? Stop me.
Like there.
Right. So probably what I want you to always practice doing is figuring out the reference angle. What's the
Yeah.
reference
60.
angle? Yeah,
60.
It's 60. That's right. So that means
Mhm.
we're going to be using, if they want exact values, they want us to use that special triangle. The
Yeah.
60 triangle looked like this. It had this, and this. This tall part here was square root of 3. This little part down here was 1, and this part over here was 2. And the 60 degrees was right here.
Yeah.
Can you tell me, SOHCAHTOA, what the sine of 60 would be?
Sine is so square root of 3 over 2.
Yep. Opposite over the hypotenuse. Square root of 3 divided by 2. That is the correct answer. So that means it's also the correct answer for sine square root of 3, rather, like that. That means it's also the correct answer for sine 300, with one minor exception. What quadrant are we in?
1.
Yeah, so what letters would I put in terms of cast?
C.
Yeah, C. That means what is always positive in this quadrant? What does C stand for?
What? Cos.
Cosine, that's right. Is this cosine?
Mhm. No.
So that means we
So
should
it's
put,
negative. Yeah.
there you go.
Mhm.
That's worth half a mark. You'll lose half a mark.
Okay.
So that means sine 60 is positive square root of 3 over 2, but sine 300 is negative square root 3 over 2.
Yeah. Okay.
Good? Makes
Mhm.
sense?
Makes sense.
So
Yeah.
now here's what I want you to take. When they say the word exact, you're going to have to figure out the reference angle and what triangle you're using.
Mm-hmm.
Good.
Yes, good. Yeah. Okay.
And then you have to use CAST, C-A-S-T. So those are the three
Okay.
big things you need to do. Always
Yes.
figure out the reference angle, figure out the special triangle we're using. Page ahead in your test, because he might have given it away in another question, what the angles are for 60, 30,
Mm-hmm.
and 45. And then you have to
Okay.
figure out if it's positive or negative based. And don't say
Yeah.
sine 60 is equal to negative whatever. Say the original angle they were looking for, 300, is equal to negative square root 3 over 2.
Yes. Okay.
Because 60 is always positive.
Yeah. All right.
Good?
Good. Yes.
Let's page through this. You tell me when to stop. They have a tan. They've given us the tan. They're saying it
Mhm.
can be anywhere in the full circle. This is important too, because sometimes they restrict it to a quadrant.
Yeah.
And they want the angle to the nearest degree. When you see that, it means you're going to be using your calculator, not the special
Okay.
triangles. So what do you think we would do with that?
Inverse
Yeah,
tan
that's right.
that number, and then you would get the angle.
You get one of the angles. So I also want you now to
One of the
drill into your head
angles.
that there's always two angles if it's within
Okay.
360. And notice it's negative, right?
Yes.
Notice it's negative. Now, if I do trig, do second tan, it does something interesting. It says it's this angle here. Get rid of all this crap. Almost. It punched out when I did my calculator and I did arctan. It punched out this
Mhm.
minus 39 degrees. Where
Yeah.
is that? Where's minus 39? Skip the
go-
zeros. There's so many zeros. Yeah.
Down.
Yeah.
It's like there.
Yeah. 39.
Mm-hmm.
But that's not a, we went negative. That's not a that's not a standard angle or terminal angle
No.
because it's negative. So
Mhm.
that's the first thing I want you to notice. It gave me this quadrant because only cosine is positive here. That was
Yeah.
the nearest negative.
Mm-hmm.
Your calculator either spits out here or it's going to spit out there. It finds the shortest distance.
Yes.
So what is the standard angle? 360.
321.
Yep. That's one of them. But remember that A means they're all positive. Sine is positive here. Tangent is positive here. And this question told me tan's negative. So what other quadrant is tan negative?
Missing one?
Yep.
No.
Yeah, no, you got it. Tan's positive here and positive here, negative here, negative here. These indicate, the cast indicates who's positive. So that means I'm dealing with another angle that's 39 degrees right here, and it's always towards the x-axis. But what's the standard angle?
It is
All the way to 180 and back, right?
42. No,
Almost. Yeah.
141.
There. So we figured out the two possible angles. One is 321 and 141. That's the only place. And to confirm it, if we took either of those angles and hit tan, we would get the number that we started with.
Okay.
That's how you know you got it right.
All right.
Also notice in the question that he left two boxes here, which means there's two angles. And he also wanted to see what we just did. Notice it's worth 3 marks. So you got to come up with more stuff that you got to figure out. Why is it kicking out a negative angle? And what am I supposed to figure out? You're pretty much always working from the reference angle to get to the standard angle, or you're working with the standard angle to figure out the reference angle.
Okay.
Always. What's
right.
What's this getting at? What are they trying to ask you here? Whenever you're puzzled, by the way, just work with whatever information they gave you. Whatever information they gave you. So what's the one thing you notice in this question that you know for sure? Like you say, okay, I know where that is.
0 and 9.
Yeah, you could easily say, okay, I'm going to start from there. I'm going to draw a Cartesian graph. I'm going to find where 0 and 9 is. I'm going to go, oh, that's right here because 0 is x here. It's way up here. 9.
Yeah.
Well, the
Uh-huh.
unit circle that we're working with only is a radius of 1. I also want you to remember that,
Yes.
which is why it has these points that are 1 away each time,
Mm-hmm.
right?
Yes.
Do you remember what I told you those points reference to in terms of sine and cosine? They're
Um,
x, y values, right?
yeah, sine is y and cos is x,
You
right?
got it. Exactly. Yeah. So, and this
Mm-hmm.
first one's 0 degrees. This
Mm-hmm.
next one here is 90 degrees. This next one here is 180. This next one here
Yeah.
is 270. And this next one here is 360. So 360 and 0 share these twice. Well, it's true even with the 9 up here. This is still how many degrees?
90.
Yeah, which means I can use these sine and cosines that I know from the unit circle. That means this cosine for this particular point
Mm-hmm.
of whatever angle this is, well, this 90 is 0, and its sine of 90 is 1. So that means if they ask me what is the value of the sine here, it's the same as the values down here. Whether it's 90 up there or 90 down here, it's the same 90, it's the same angle.
Okay.
Often they won't make it like this. This is kind of a weird thing to give you. Sometimes they'll give you this point. Where's that point? Not always that point, but a point like that. Where is that point?
4 over and then 5 up.
Yep. 4 over. We'll just say 1, 2, 3, 4. And then we'll go
Mhm.
1, 2, 3, 4, 5. And we'll say it's right there.
Mm-hmm.
Instantly, what I want you to do is draw. Oh, sorry. Instantly, what I want you to do is draw a triangle like this,
Mhm.
straight to origin. Straight to origin. There we go. Then I want you to draw it straight down. And then straight to origin again like that. So that we form a 90-degree triangle.
Okay.
Well, I know the coordinates up here are 4, 5.
Mm-hmm.
And you told me, well, I went 4 over and I went 5 up. So what's the dimensions of the side of the triangle if I went 4 over and 5 up?
4
Yep.
and then 5.
Which means you can figure out the Pythagoras right here.
Mm-hmm.
It's 5 squared, 25, plus 4 squared, 16, 41.
16.
So that means
Yeah.
we wouldn't ever solve it. We just put square root of 41.
Mm-hmm.
Well, now whatever this angle is, let's call it x, I can figure out using SOHCAHTOA what its sine is. So what is sine of x? What does so mean?
It is the 5 over
Yep.
square root. Is that
41. 41.
Yeah, 41. Yeah.
What's the cosine?
Cosine is 4 over square root 41.
Yep. What's the tan?
Tan is 5 over 4.
You got it. So this obviously isn't a unit circle. It's got weird
Mhm.
tangents, weird signs. It's got weird numbers, but they'll ask stuff like this. So you got to form
Yep.
your new triangle and figure it all out.
Mm-hmm.
Sometimes they'll give you a weird thing like this. I've seen this question a lot. Instead of giving this coordinate, they'll say there's a coordinate that we've gone to, X and Y, they'll say.
Mhm.
And they'll say the sine of this angle down here, let's just make the little theta thing. They'll say the sine of that theta angle is
Mhm.
4 over square root of 6 or something like that, whatever. We'll say 4 over 5.
Yeah.
And you say, well, that's not, I don't know the X, Y, or anything, but you already know that sine is also opposite
Mm-hmm.
over the hypotenuse.
Yes.
Well, that means this number here is the opposite.
Mm-hmm.
And this number here is the hypotenuse,
Mm-hmm.
which means I can figure out this number here by reversing a squared plus b squared is equal to c squared. And I figure out it's 3. And now that I have those 3 numbers, I can figure out my sine, my cosine, and my
Mhm.
tangent of this particular angle. That's a common question where they give
Yeah.
you the sine and they ask you for all the cosine and tangent.
Okay. Okay. Yeah.
Let's just keep paging through this. This one is a cosine law question.
Yeah.
You can probably do it on your own. This one
Mhm.
is great. This is a perfect example of what I just said.
Mm-hmm.
Okay, so we got a triangle.
Okay.
They haven't given us the coordinates, but they tell us it's in what quadrant?
Uh, 2.
Two. Yeah. So we know we're dealing with an arm down here in two. We just don't know where it is. We don't know where it is. So we'll just put it anywhere.
Mhm.
But they tell us there's an angle here, and we know it goes to a point here. We don't know what the point is, but we can just automatically draw a triangle
Yeah.
by going straight up, straight across, and using the red line as the hypotenuse. Now they
Yeah.
tell me
So
this bit of information, right?
yes. Yeah.
And what does so tell us?
That the one side is 2 and the hypotenuse is 3.
Right. And then I can use, okay, well, if I don't know this one, a squared plus b squared, which is 4,
Mhm.
is equal to 3 squared. 3 squared is 9.
Mhm.
So I know a squared is equal to 9 minus 4.
Yeah.
So a squared is equal to 5.
Mhm.
So that means a is equal to the square root of 5. So now I have another side. Square root of 5. Yeah. Sorry. You understand how I got there?
I do, yes.
Okay. This is a common question. He's throwing it. I just pointed that out last question, and he's got it right there. So I got 3, 2, and square root of 5, which means I can now figure out, first of all, they give us the sign of this angle here.
Mhm.
It's in quadrant. Oh, you know what? I drew it in the wrong quadrant. Quadrant 2 is not there. Quadrant 2 is
Yeah.
over here.
Okay.
But it doesn't matter. We still get the same values. Quadrant 2 is over here. Go straight down, go straight across. That means the length of x is square root. It's negative square root of 5 because we're in this quadrant, right? Because we went this way.
Yeah.
2 here and 3 here. So 2 is still positive, and that's why the sign is positive here.
Mhm.
But now I have to figure out
Okay.
cos is COA.
Mhm.
What does COA stand for?
O over H, so 2 over 3.
Yep, you got it. So cos of this angle, we'll just call it A. And tan is?
And is 2 over square root of 5.
Yep. Now you only lost 1 mark or half a mark.
Mm-hmm.
What did we do wrong?
That tan is positive, cos is negative.
So we're in this quadrant, so we should do cast. Where does the C go?
CASTO. So they're both negative.
That's right. Which is why when they gave it to us, it's positive, because that's the quadrant. It's positive.
Okay.
So if you don't add those negatives, you're going to lose some marks.
Okay.
Good?
Good, yeah.
Just remember, cast applies no matter what.
Mhm.
So they just wanted tan in this case, but we figured out both of them. Doesn't matter. So that's all that page. Right?
Okay.
So we're going to go to
Yeah.
this page. This is sort of basic stuff. You tell me what's not a quadratic here. Start with this one.
That is not one.
Nope, that's right.
Yeah.
This one?
Is a quadratic
Yeah.
as well?
This one.
Not a,
That's right. This one.
nope.
That's right. This one.
Yeah.
Yeah, that's right. This one.
Yeah.
Yeah, it's in standard form. This one.
Mm-hmm. Yeah.
That's in vertex form. This one.
No.
It is.
It is.
What do
Oh,
they do to
okay.
fool you? So it's good to know. Always
They-
spot your weaknesses, not your strength.
Hmm.
What do they do here to fool you?
I thought because there was the X, 3 X's.
That's right. You might say, well, there's 3 x's, but notice that they're not multiplying. So
Mhm.
here, when they multiply over here, x times x times x, you get an x cubed. And an x cubed is not a quadratic. Same with this one. This
Okay.
x times this x, but this x is squared. You get an x cubed. But
Okay.
these are all adding or subtracting one another. And the
Mhm.
trick they've done here that they fooled you with is all they did is put it in the wrong order.
Okay.
And even though there's nothing in front of that 3x, that automatically implies that it's positive.
Yeah.
So that means there should be a positive in front of it. Now that I've put it in this order, it's clear that it's a quadratic. There's a squared. That's just the middle term, and it's not squared.
Yes.
So that means when they're adding, as long as there's a square there and just one x and a number, it's a quadratic. You don't even have to have this number.
Yeah.
And you also don't have to have that 3x, and it's still a quadratic as long as that x squared is there.
Mm-hmm. Okay.
Make sense how that fooled you?
It does, yeah.
Okay, what about this one? This one also is annoying.
No, because the y's, there's two y's.
That's right. It's y squared. If we were to get rid of that square, we'd have to square root both
Mhm.
sides, and this here is not a quadratic.
Yes, okay.
Okay. You will be studying a function like that, but yeah. Okay, so this is about that's not quite completing the square. Yeah, it is sort of. Yeah, this is a common question too. Do you remember how we should go about solving this one?
I do, yes. You
Okay.
substitute the
You substitute what you know.
the
Yep.
the vertex in, and then the x and y values.
You got it. Yeah. So this 3 is the reason they put the minus p in the formula, to remind you
Mhm.
that if it's positive 3, it's now negative 3.
Yeah.
And this 50 just goes down here at the q. And then to solve it, you're right. We would put this where there's y,
Yep.
and this where there's x, minus 5. So we would do minus
Okay.
5 minus 3 here is minus 8.
Yeah.
Then we do minus 8 squared,
Mhm.
which becomes 64.
Mm-hmm.
And algebra says that I have to get rid of the 50 first.
Yeah.
So become 2 minus 50 is equal to 64, A64 or 64A.
Yeah.
So I
Yeah.
get 64A is equal to negative 48.
Yeah.
Then I have to divide both sides by 64. And then I realize my top number and my bottom number can both be divided by 12. 24, 36. No, they actually can both be divided by more than that. 12, 14, 18. Half of this is 32, 16. So this one, when I divide it by 16 up top is minus 3, and this one when I divide it by 16 is 4. So that's A. Once I have A, I go back to the original formula, and this is important.
Mhm.
And in this format here, I leave the x and the y alone. I leave the x and the y alone, like this. And I fill in all the information I have now. So I know that that's now minus whatever we had. I think we had minus 3. Yeah, 3. I know that that's 50 because they told me the vertex here was 3 comma 50. And I now have figured out that the A is negative 3 over 4. So now I rewrite it like that. And I leave the x and the y like this. This is the answer he's looking for. So that's a messed up 50. So he wants the final formula to look like this, where you found out the x value, the y value, and the a value. Good?
Good, yes.
Yeah,
Okay.
he gave you 2 of them, so it's probably on the question. The trick here is they've given you a point, but it's hard to see the point. It's really 0, 4, because y intercepts the x is 0. So he's given you a point. It's just 0, 4 this time.
Yes.
Same technique. You're just using a mysterious point that's hard to see at first.
All right.
You can see from this, to find the y-intercept, we just make x 0. So the y-intercept is what point? What's the point?
That's 7.
Yeah, but always get in the habit. I saw even your teacher had it 0, 7.
0, 7.
Yeah,
Okay.
you're going to lose points. X-intercept, we have to factor it.
Mhm.
We get x minus 7, x minus 1. What are the x-intercepts? This was the question you sent me today, by the way.
They are
Let's see if you can do it.
x X7 and X1, right? Because they switch. No?
Yeah, that's right. But how would I write those as coordinates? If the y-intercept is 0, 7, how would I write the x-intercepts if you told me it was, if the factors came out as x minus 1?
7, comma 0,
Yeah,
and then 1, comma 0.
that's right. Just always remember that. There's always an x, y coordinate. 1,
Mhm.
0, 7, 0. Now, here's what your teacher clearly wants you to learn that we didn't quite do. If I were to draw those, right?
Mhm.
1, 7 is roughly here, or 1, 0 rather, roughly there. 7,
Yes.
0 is roughly there.
Mhm.
Your teacher wants you to be able to figure out the point in between them, and he gave you a formula. It's this plus this divided by 2. So 7 plus 1 is what?
8,
Yeah, 8 divided by 2 is what?
4.
Right, that means the point in between is 4.
Okay.
4, right there. The reason
Mhm.
that works is because they're clearly 6 apart, right? 7 and 1.
Yes.
But 3
Yeah.
away from 1 is 4. 1, 2, 3, 4. Or you could just do what he did. You add this one and divide by 2. The reason that's useful is because sometimes this point here won't be
Mhm.
clean like that. It'll be over here like minus 3,
Yes.
0. Now we have to
Okay.
add 7 plus minus 3, which becomes 7
Mhm.
minus 3. What's 7 minus 3?
4.
4 divided by 2. What is that?
2.
Yeah, the reason I wanted to show you this is because the point between minus 3 and 7 is right here at 2.
Yes.
So that technique's great to use for negative numbers, right? Did you understand that?
Yes. Yeah, that makes sense. Yeah.
So in this case, we determine that the axis of symmetry, here's how we write axis of symmetry, is x is equal to, what number did you determine?
4.
Yeah, that's how we write it. X is equal to 4. And that, when we write that, that just means a vertical line at x is equal to 4. But the benefit of that is whatever the axis of symmetry is, that x value is also the x value of the vertex.
Okay.
What technique did your teacher want you to do here? Do you remember what he did?
For the vertex, he substituted the 4 in
Yeah, for what value?
X.
Yeah. So instead of x minus 8x plus 7, I would write y is equal to,
Y is equal to 4 minus 8 times 4 plus 7.
yeah, minus 8 times 4, I'm just going to let you off the hook, is minus 32.
Mm-hmm.
If we do all this together, 4 plus 7 is 11.
Yeah.
11 minus 32 is minus 21.
Mm-hmm.
I think that's it. Hang on.
用第一个是吗？
4 minus 32 is minus 28 plus 7 minus 21, yeah. Which tells me the vertex is where?
Which tells you the
Oh, you know what? I
vertex
screwed that up. It's x
is-
squared. It's x squared. So 4
okay.
squared is 16.
Mhm.
16
16.
minus 32 is minus 16.
Mm-hmm.
And minus 16 plus 7 is minus 9.
嗯，
So that
Yeah,
tells
so
me
it
the
is.
vertex is where?
4 and
它才会等于180
-9.
Yeah. You always do 4, comma, negative 9. There you go.
Yes.
That's the technique he uses. So once you found the axis of symmetry, you could just substitute into the equation. He did not want you completing the square. He wanted you to use the axis of symmetry.
Yes.
Okay.
Okay. Yeah.
That tells me the domain. Let's see if you can remember this. Oh, does this have a minimum or maximum? Let's have a look. Is it facing up or facing down?
It is facing up.
So that means it has a min or a max.
Min.
Yeah, and the min should be at the same location of the vertex. But did you ever ask your teacher what format he wants for the min? Does he want you just to tell him
I
the
have
vertex?
not.
Yeah.
I think it's probably just a vertex. So hey.
Yeah, I hope so. There's 3 blanks here. Maybe you can ask him really quickly before the test.
Yeah.
When you want max or min, do you want me to tell you the vertex or the y value? Like, because the range is written like this.
Mhm.
We've discovered that the vertex is 4 comma minus 9. Okay.
Yes.
All right. And I'll skip everything else we did here. It doesn't matter. So we got 4 comma minus 9 is the vertex. We know that.
Yes.
We also know it faces up. It faces up. That tells me the lowest point on this graph will be right here at 4 comma minus 9.
Okay.
That's the min value. That's the lowest point occurs when x is 4 and y is minus 9. But I would write the range like this. Y is bigger or equal to minus 9. The x value always dictates the left and right of a graph, this way and this way, the x values, and the y values always dictate this. So the x values are always called the domain, and the y values dictate the range.
Okay.
Parabolas, because they start at one spot and either go up or down, have a range that's limited by the y value here. But you must always include it. Y is bigger or equal to minus 9 because minus 9 exists on the graph. The domain of every parabola is XER.
All right.
The only time that's not true is when he gives you real life situations, but he didn't give you any in this. So we'll just say XER. So in answer to this, I'm guessing he wants them, you would say it's a minimum but it's weird how he's got 3 blanks here. That's why I'd rather you ask him. Well, you have an answer sheet, don't you? You can figure out what he put in there.
Oh yeah, I do have an answer. I can check.
So it's a minimum. I think it's going to say a minimum of minus 9 when x is equal to 4.
Yeah. Was it the last sheet or the second
Well,
one?
let's see. It is test number 3.
Yeah, he says minimum of minus 9 when x equals 4.
Yeah. So all he did was he put in the words right here. We knew the vertex was here.
Yeah.
So all he did was he said, well, it's facing up. So he said minimum. And then he said, we know the y value is minus 9, and we know it occurs when x is 4. So that's all he's saying. He's telling you essentially the vertex.
Okay.
Okay. Domain would be, what's domain? I just told you for all parabolas, domain is?
It is like the
X is
9.
nope. So domain of a parabola is always x is all real numbers.
Yeah. So it's infinite, hey?
Yeah, infinite. Goes left and right forever.
Yeah.
If we were to pull back from a graph, we could see it goes on to every x value possible. Only the range is limited. What's the range of this if there's a minimum?
Is the lowest y that it goes.
Yeah, so how would I write that? I just told you a couple seconds ago.
It is -9, so it's what?
So first, is this a minimum?
Yes.
So all y values are above whatever the minimum is. How do I phrase that? All my y's on my graph are above this minimum.
The y's are bigger.
Yeah.
Greater than or equal to.
That's right.
-9.
Yeah. So all I have to remember is it's the y value of the vertex.
Yeah.
And if it's a minimum, I say y is bigger or equal to that number. And if it's a maximum, I say y is smaller or equal to that number. And what I'm saying is all the y values on my graph exist either above that number or below that number. And include that number. Make sense? So I want you to remember that ranges are all the y values that are possible on the graph. And domains are all the x values that are possible in the graph. And I also want you to remember that all parabolas, except real life questions, which he hasn't included here, are always XER, and that the range is always based on the y value of the vertex. Good?
Good, yes.
All right. This one, he wants you to graph the last question. And notice, always look at how many points he wants. In the
Mhm.
last question, we figured out the x and the y intercepts were here
Yes.
and here. We also figured out the vertex, and it's off the graph, but it doesn't matter. We figured out the vertex was way down here at 4 comma minus 9. And the very first question, we figured out the y-intercept is here at 0 comma 7. So we have 1, 2, 3, 4 points. 4 comma minus 9. But in his question here, he says he wants 5.
Yeah.
How would I come up with another point? I got 4 points like that. And he wants 5. And I've got y is equal to x squared minus 8x plus 7.
Yeah. You got the
We got the vertex, 4
vertex,
4 minus 9.
yeah.
That's right down there.
The x-intercepts,
Oop.
the y-intercept, and then you can, with the axis of symmetry, you can find the other like top point thing.
Yeah, so you're saying since the axis of symmetry is 4 here, and
Yeah,
this
you
point
can
here
count.
is at 0 comma 7, how far away is that 4 from 0 comma 7?
4.
Yeah, which means
Away.
it's at 4, and that means the other side is how many away from the axis of symmetry?
4.
So what would that x value? Yeah, 8 comma
7.
Yeah, it's going to be on the same y value, 7. That's right.
Mm-hmm.
So that's all he wants. That's the easiest way. The other easiest way is you can pick any x value and just plug it in. Right? You could just say, okay, I'm going to pick, I already have 1, I already have 0, I'm going to pick 2. So I put 2 in there and I get 4 minus 16 plus 7. So I get 4 minus 16 is minus 12. Minus 12 plus 7 is minus 5. So right away I can go, okay, negative 2 comma minus 5. That's another way. You can just plug in a value there. Good?
Yeah, good. Yeah.
All right. So then he asks you to figure out the number of intercepts here. And intercepts are based on when y is what? X-intercepts are when y is what?
When 0.
Yeah.
When y is 0, yes.
Now, because you're going to get tired, and I urge you to get lots of sleep and eat a good breakfast, that's 2 key things that'll help you test. If you stay up too late in a test,
Yeah.
it starts being a negative.
Mm-hmm.
Because your brain can't work tired and your brain can't work without food. So make sure you eat a good breakfast or whatever, lunch, whatever. So if y is 0 here, how would I go about solving x?
So solve x. You want to get rid of the minus 13?
Yeah. So it comes over to the left side and I'm left with this. What's my next step?
You want to divide -3?
Yep. So whenever you divide by a negative number by a negative number, they essentially become positive.
Yes.
Okay, so you can just get rid of those negatives. So I got 13 over 3.
Mm-hmm. And then
it's gone now. There we go, like that.
And then you do square root.
Yep.
On both sides.
Yeah, now you can either put the square root on each one or you can put the square root over both of them. Now the square root's gone. However, when I do a square root, I have to do something weird. What do I have to do? What's the little trick?
What do you mean?
There's a little rule when I do a square root of something, I have to do something to the side of the answer. Yes, I put a square root there, but there's 2 possible answers.
Get the square root?
Once I do a square root,
plus or minus.
One of them is plus. That's right. One of them is plus.
One of them is minus.
And one of them is minus.
Yes.
And that is because the square root of 9 can either be 3 or minus 3. And that's because if I square minus 3, I also get 9. If I square 3, I also get 9. So that means the square root can be minus 3 or 3. So I've got this now. I've got plus. Let's do this top one. I'm almost done it. What do I do?
So plus 6. So
yeah. So this,
Three
believe it or
over.
not, is a legitimate answer. Square root of 3 over square root of 13 over square root of 3 plus 6.
Yeah,
And then what about down here?
it's just -6.
It's still plus 6, but this one
Oh,
on
fuck.
the left is negative. Right?
Oh yeah, so it's okay, okay, okay.
So that's my two answers. So how many x-intercepts does it have?
2.
Yeah, weird ones, but there they are.
Uh-huh.
Okay, same
Okay.
technique with this. Y is 0.
Mm-hmm.
Walk me through it. Make no mistakes, or I'll give you take a mark off.
Okay,
So y
so
is
y
0.
is 0. Okay, so you want to -5.
Yeah. So we get rid of this 5. It comes over here and
Mhm.
becomes -5. Okay, next.
Yep. Then you want to divide a half.
Yeah, you can divide a half. Now, let me teach you another way of getting rid of that half. What's the opposite of that?
Negative a half.
No, it's reciprocal, I should say. If reciprocal is just flipped upside down.
2 over 1.
Yeah, if I multiply that by 2 over 1, it cancels.
It does, yes.
So,
Same there.
and now I can multiply this. Remember that they're multiplied, though. What's 2 times -5?
2 times -5. -10.
Yeah, over 1. So, -10. So that's the easier way, because if you divide by a half, you're stuck with figuring out how to divide a fraction by a fraction, and it ends up being the same thing, -5 over 1
Yeah.
times the flip of that.
Yeah.
But
Okay.
that's a lot of torture. Instead, I can just
Mhm.
multiply by 2 over 1 over here. So I get this. X squared is equal to minus
-10.
10. Now, what's interesting about this?
Square
How do I get rid of the square?
root it.
Yeah. Now, look at this. Square root of -10. Possible?
Doesn't work.
That's right. So there are how many x-intercepts?
0.
That's right. You got it. This last one will probably have 1. Okay, what do I do
Yeah.
first?
Make y 0.
Yeah.
Okay, and then you want to times 4.
Yeah, well, this is multiplying it, so I have to.
Divide 4,
Yeah.
sorry.
On both sides. 0 divided by -4 is 0 still.
Yeah. Then you square root
Yeah, square root of 0 is?
0.
Yeah, you don't have to add plus or minus for 0, so it's just
Mhm.
0. So I get 0 is equal to x plus 5.
Yep, and then you do -5.
So x is equal to -5 is my only answer. So how many x-intercepts?
1.
Yeah, and that is because if I look carefully, I can see that this is in vertex format, and there's no y value here. So it tells me the vertex is right on the x-axis.
Yes.
Okay, and facing down.
Okay. Yeah.
So that means its range is, what is its range? If it's facing down, and this is the vertex -5, 0. What's its range?
The range is -5.
Nope. Range
zero.
has to do with
okay.
what? Y values. So what's the range?
Mhm. 0.
And how would I write that? Y is all values of y on this graph are.
Y is smaller than or equal to 0.
Yeah, that's the range of that one.
Mm-hmm.
And that's important to know. Okay.
Yeah.
The range is, once you memorize it, it's easy. Range has to do with the y values. The x values on this don't matter. This is a tough one because you got to complete the square.
Yes.
So practice completing your square.
Mm-hmm.
What would I do? Let's just not do the numbers. Just tell me what I do.
Okay, so you substitute -1/2 out of, or you bring the -30 over first,
Yeah.
then you substitute -1/2.
So what you call
That is-
substituting -1/2, I'm just going to let you know when
Or
you
pull
talk
out.
out in school, it's called factoring out. Factoring out.
Okay.
So it means
Factor
that
out.
you're essentially dividing both those numbers by -1/2. In this first one, it cancels. What happens in
Yeah.
this one?
It becomes
What's -12 divided by -1/2?
24.
Yeah, very good. Also notice the negatives cancel. That's the first thing you should do is say, okay, well, those negative don't matter. So that means I'm left with x squared plus 24x once I factor that out. Plus 24x. How do I complete the square?
You do half
Yeah,
of 24,
yeah. So I got negative a
which
half out front, and I got
is,
x plus 12 squared,
yeah, and then you do 12 times 12,
which
which is
is
144.
144. So I have to subtract 144.
Yeah, and then you pull out the 144 and times it by that number,
So the
which
negatives will
it
cancel. It'll become positive.
would be
It's essentially being divided by, yeah,
78.
yeah, close, 72. So it becomes
72.
comes plus 72 when it's out. What's plus
Yeah.
72 minus 30?
Um, 42.
Yeah. So what's the vertex?
It is, the vertex is negative 12 or negative 12 comma 42.
Yep. And what's the range?
The range is y
Mm-hmm.
is less than
Mm-hmm.
or equal to 42.
You got it. Perfect. Very good. All right. So the only one you got to practice now are we did our, well, we did that. I think we did all of them. Yeah. That's that one. That's
Hmm.
pretty good. Okay. Let me make sure that we got them all. We did that one. I would practice some sine law if you're weak on it. Some cosine law. It's
Yeah.
pretty good. X, Y intercepts. When does the minimum occur? We did
Hmm.
those. You did those fine.
Yes.
This is fine. This is, you have to do inverse sine. Oh yeah, we didn't quite do
Hmm.
this one. So this one is all a mix of it. Okay. If you want to do one more
Yes.
question, you can say it, or you can just shoot me questions if you need to study.
Hmm. Okay. Yes. All right.
Okay. Although I'm only going to be up for another hour, I think.
Okay.
All right.
No worries.
Do you have
Yeah.
any questions of these?
Right now, no, not
So when it says that exact
really.
value, you are doing what?
Using the perfect triangles
That's
or
right.
whatever they're called,
Exactly.
like the
Now it's
30.
okay.
Yeah.
Perfect. Fine. And then here you can see that we're using our what?
Our inverse sine law
That's right. No, inverse sine on our calculator. That's what I'm getting at.
on, yeah, that's what,
Okay.
yeah.
What's a reference angle? They tell me here that this has a reference angle of 75 degrees.
Uh-huh. So
What's a
basically
reference
it's
angle?
that's like the little one, the cute one.
Yeah, cute. That's right. So it could be over here and it could be 75 here. So can
Yes.
you tell me
Hmm.
one reference position or one standard position then? If
Yeah.
this is 75 here, what's this angle there?
105.
Yeah.
Right.
So I'm going to give you a little hint. When it's this quadrant, it's 180 minus your reference angle. When it's in this
Okay.
quadrant, it's 180 plus your reference angle. When it's in
Hmm.
this quadrant, it's 360 minus your reference angle.
Okay.
That just makes it easier. 180 minus it here, 180 plus it here, 360 minus it here.
Okay.
Just makes it
Okay.
faster for you.
Mhm.
Exact value, we've got to use our special triangles. When I look at 210, I can see that that's in quadrant 3, and it's 30 degrees past the 180. So I'm looking at 30 degrees here. And in
Yes.
quadrant 3, only tangent will be positive. So this is going to have a negative. Cosine is going to be negative. So I have to find my special triangle for 30 degrees, and whatever is cosine for it, I have to make it negative.
Hmm.
This does the same thing. It's telling me right here. Right here, when I look at this, I can sort of realize, oh, that looks like one of the values for they say exact right there. So I'm using my special triangles.
Yes.
Just realize that sine is positive in two quadrants, quadrant 1 and quadrant 2. So there's two possible answers.
Hmm.
And it says without your calculator because it says exact. This is exactly what we did before. There's a point that's not part of the unit circle. It isn't standard. But based on that point, I can draw a triangle that has a height of 3 and is -1. So we're in quadrant 2. So that means sine is going to be positive. Everything else is going to be negative. And I can figure out all my my values. It says exact ratio. Just be aware that because this is not on the unit circle, that it's going to be just drawing your own triangle. Do you know what I mean?
Yeah, I know what you mean. Yes,
Okay.
yeah.
This here is the going to be the sine law because it goes angle, side, angle. This here is going to be the cosine law because it's 3 sides.
Mm-hmm.
This here is going to be, well, the coordinates of the vertex are right in there because you have vertex format. Y-intercept
Yes.
will be when x is 0. So when x is 0, it's pretty easy to figure out. X-intercept is when y is 0, so you just do algebra. It's facing up,
Yes.
so it's a minimum. And then you do it again with this, except this is in standard form. So this one, on this one, the second one, you have to factor and maybe use the axis of symmetry instead of, okay? And then you already
Yes,
did
okay.
that. And you already, so I think you'll be good.
Yeah.
So this one's just a
Okay, yeah, I
couple
think-
more cos laws and sine laws.
Right.
When's the test? Afternoon or morning?
It is tomorrow afternoon. Like,
Okay. Then you can still shoot questions.
yeah.
Shoot them tonight.
Yeah.
I'll answer them in the morning.
All right, yeah,
If
no
you have any
worries, yeah.
questions. And then remember, get a good lunch. Don't try to cram. It's better if you're relaxed. When you open the test, always do the ones that are easy first. Then build
Okay.
up confidence and go do the other ones. And then if you have time, always don't leave the classroom. Always just spend the time checking your answers.
Yeah.
Okay.
Okay.
And then when you get
All
good
right.
marks, you'll get encouraged and it'll make it easier. But if you
Okay.
handicap yourself, if you stay up too late or whatever, if you don't eat especially, you're actually hurting your chances. So give yourself as many chances as you can. I think I
Okay.
did all of these questions also on video, which you can reference to.
Yeah, okay.
Okay.
All right. Yes.
All right.
I'm dialed in, yeah.
Yeah, excellent. Good
Yeah.
for you. I can see improvement, man. So just keep
Yeah.
at it. Keep at it.
Mm-hmm.
All right. Take care.
All right. Yeah, thanks, man.
All right.
All right.
Bye.
Have a good one.
You too.